new topic, and we call this as center of mass. Okay, now this topic has a very great significance. Like when we consider the center of mass, yes, hold on. So let's suppose when I'm talking about center of mass, why it is coming? Why center of mass? Yes. Now, to talk about this, there are many things, many conclusions with which we can talk about it, or with which we can conclude it. But mainly, I want to talk its physical significance. Now, let's take an example. Like example is, there is a road, and on this road there is a car which is traveling. Got it? And in this car there are many marbles, small marbles I placed, and they are very mild. Like this acceleration of car is enough to affect the state of the marbles. Are you able to get me on? So what you will observe basically, when you are going to see these marbles, when you will look into these marbles after the motion, what you are going to basically observe? Tell me. They will they will move here and there. Yes. So why they will move here and there? Actually, point is when you look into, yeah, actually the idea is that they will move here and there, and they will arrange themselves in some such kind of way. Yes, their arrangement will be something like this. Correct. Now, if you look into this arrangement, why this arrangement has appeared, that means that when the whole system was accelerating, some kind of force was acting, and it was acting in such a way that the whole particle was feeling this force. Yes or no? Next idea is, let's suppose when you throw a hammer, okay, you throw a hammer in a projectile kind of way, what you will observe, that this hammer goes exactly in projectile way. How is that even possible? Yes or no? If I am throwing some hammer, and that too going in a projectile kind of way, like this way, it is only possible that it is only possible if the whole mass of the hammer was located at one of the point, and that mass was following this trajectory. Yes or no? Yes, means basically to follow this, means this particular trajectory can only be followed if the mass is concentrated at any point. Yes or no? But the question arises that how to observe that. 1 minute. To, yeah. But the question arises, how is that possible? So this possibility of concentration of masses at one point is called as center of mass. Are you able to get me or not? So what is center of mass? Let's talk about that. Okay. So first point, it is an imaginary point. Okay. At which entire mass of the system of the body, or entire mass of the system, or entire mass of the body you should write. Okay, not system. Or you can say entire mass of body, or entire mass of system of particles. Okay, feels to be, or feels, or you can say that uh, feels to be concentrated. Are you able to get me or not? And that is called as center of mass. Okay, this is another point, is this is that point. Okay, about which the body can be balanced. Are you able to get me or not? And for any uniform mass distribution, you can say uniform mass distribution system, center of mass in simple form COM will be present at, yeah, geometrical center. Are you able to get me or not? Yes. Now, why this is coming means, question was for a long that why this is coming. So the idea of center of mass has a very great depiction. Okay, so you can say in simple form COM is nothing but is a point. Okay, remember it is a what? Point. It can be in or out of any system. In simple, the conclusion of all these 3 points is this, that center of mass is a point in and out of a body or a system. Okay, where we assume or where we assume that the whole mass is located. Okay, or concentrated for translational analysis. For which analysis? Yeah, translational means all the systems moving in some way, are means they are experiencing some force and they are moving somewhere. Are you able to get me or not? Okay, so basically remember that translational analysis is very very necessary for center of mass, and if it is center of mass, it is says that whole amount of force, that let's suppose if a body is experiencing some amount of force, the summation of all the forces is given as mass into acceleration of that whole body, and therefore net momentum of the whole system is given as mass into total velocity. Are you able to get me or not? So these are my translational coordinates which we actually try to understand, or is we say these are my translational variables, you can say. Okay, so we relate velocity, momentum and acceleration with the force, then we call it as translational quantities. Are you able to get me or not? Let's talk about one example of this. So let us pick up one example. Think that there is a rod. Got it? And let us make it like this. Okay, and it is fixed over some point. Let's suppose it's fixed over here. Got it? Now, 1 minute. हाँ प्रभात, आएंगे आएंगे आएंगे। सुनना बस, मैं एक 1:30 तक आता हूँ। 1:30 के बाद देखते हैं, अगर वॉशिंग मशीन वाला आएगा तो ठीक है, नहीं तो चलेंगे, ठीक है, निकल जाएंगे। हाँ हाँ हाँ, खाना खा के ही निकलेंगे भाई, कैसे भी। हाँ ठीक है ना, टेंशन ना ले। कहाँ है तू? ठीक। अच्छा अच्छा अच्छा, ठीक है, तो रजनीश को ही बोल देंगे, ठीक है ठीक है ठीक है। ठीक है ठीक है, चलो। चलो, 1:30 पे आता हूँ, ठीक है। ओके, सो point is simple that when we consider, let's suppose consider a rod. Okay, yeah, that's a hinge. Okay, and the length of the rod is L and mass of the rod is M. Are you able to get it? The question is, means we are ignoring gravity. Remember, it's written ignore gravity. Okay, and point is very very simple that if it is rotating, then find the tension in the rod. If it is rotating with angular velocity omega, means this hinge is helping the rod to rotate, right or not? With angular velocity how much? Omega. Then find the tension at rod. Then find the tension in rod as a function of x. Means basically the idea is why I brought this example. This is an example of a circular motion. But let us bring this with the help of center of mass, then you will get something out of it. Try it. मैं लाइव क्लास ले रहा हूँ, मैं बात करता हूँ, ठीक है। हम्म। बोलो। मैं लाइव क्लास ले रहा हूँ, मैं बात करता हूँ, ठीक है। हाँ। अरे भाई, मैं क्लास ले रहा हूँ। हाँ। Tell me, what will be the answer? See, idea is, a hint is, just consider a hypothetical scissor at a distance x. Yeah, and cut it over there wherever you want to find the tensor. Then you can get the answer in easy. Yeah, so like let's suppose if this is my hinge. Okay, then let us consider this latter part, means at the distance x. So we know that at distance x, when we consider distance x over here, then let's suppose this distance x is there. So this will have mass m dash or not. And you know that mass per unit length we can define. I have taught you how to cut the object in work energy power, na? Yes. Yeah, so mass per unit length is m by L. So mass in the length x, this is L minus x basically, yes or no? So mass in length L minus x will be m by L into L minus x. Are you able to get me or not? So that is my mass. Now look over here. Where will be the tension? If you look into this, then the tension will be located above this side, and here will be my, in this side, if I sit on this mass, then the centrifugal force will be outside. Yes or no? Correct. Yeah, but what is that centrifugal force? M omega square r. Question arises, what will be the radius for this mass m dash? L. No. Now this is the idea. See, I asked you to find the tension for the part x. So I have to consider this m dash. Basically, this m dash, the test means you can say that the particular tension is generated due to the weight m dash, got it or not, or due to the mass m dash. So let us consider that this mass m dash is located at the center of this rod. Are you able to get me or not? So what is its radius? Its radius is r is equal to x plus L minus x divided by how much? 2, which can be written as x plus L divided by 2. Are you able to get me or not? I don't know. So then at that point, if I want to find like centrifugal force, it is m dash omega square r. Is that clear? So question arises that what is this what is this tension if I want to find? So simple. Now I can write tension. We know that sir, tension is m dash omega square r of center of mass of that part. Yes, m dash is m by l, l minus x omega square. Okay, and r center of mass is x plus l divided by how much? 2. Are you able to get me or not? So this is a plus b, a minus b. So I can write t is equal to uh, m by l, l square minus x square omega square by 2. That's my tension as a function of rod. And this is quite easy if I follow the process of center of mass. Yes or no? Are you able to get me? Now, the main idea is like basically what is happening at every point, the tension is increasing for the rigid rod. So one idea is this is method 2 if I follow the center of mass. Another method is you can consider a small mass dm. Got it? Like let us suppose I select a mass dm, and then the tension on this will be how much? Dt, which will be dm omega square x. Are you able to get me or not? Correct now. So that dt I'll integrate from where? Basically look over here. The net tension, many people think that the tension at the center is 0 for the rod. But actually, remember, opposite happens. For the rod which is rotating with the hinge, tension is 0 over here. And tension is maximum over here. Are you able to get me or not? Is that clear? So you have to remember, so when you do the integration, this is method 2. Okay. So if I use dt as dm omega square x, dt will be what? Dm, we know that m by l into length dx. Yes or no? Omega square x. And then I integrate this. Are you able to get me or not? But where to where? So basically I have to integrate. Let's suppose t is 0 over here. So I have to go from l to distance x to find 0 to tension t. Are you able to get me? So this one will give the answer. Are you able to get me or not? So there are two ways, either the particular idea of going or finding through the center of mass, or either finding through dm. Is that clear or not? Okay, so write it fast, and then done. So okay, is it clear? Can we move ahead? So this is the idea of center of mass. Like as you brought the concept of center of mass in the picture, you have the idea that you can include every portion of it, everything like mass by length, length by mass. It gives us the clear approach, means it gives a translational approach how the masses will move. Are you able to get me? Now, as we move along the center of mass, we saw there are many two kinds of systems, and there are two system of particles. So let us write one point. Let us define one quantity called as system of particles. Okay, what it is? So it is nothing but based on distribution of mass, there are two kinds of means you can say the based on distribution of mass, system of particles is of two types. Are you able to get me or not? One is called as discrete, another one is called as continuous. Okay, so let us talk about the first one. Let us talk about, okay, okay. So there are two kinds of system: discrete system of particle or discrete mass system, or continuous system of particle. Are you able to get me or not? So what are discrete systems? Nothing. When lot of individual, okay, masses uh, are there in such a way that there is there is no link between them, we call it as discrete system. Are you able to get me or not? I'll talk about that. Let me think. Now, when masses are linked to each other, basically they are called as continuous system. Now let's take an example. Let's suppose there are two particles. Okay. So if they are discrete, then what will happen that this distance gap, let's suppose if I select two particles and radius of each particle is, one particle is r1, radius of another particle is r2, and this distance gap between them is d. Okay, here also same, radius is same, r1, and another one is r. Yes, and distance gap is, let's suppose, d. So idea is, when this distance gap between the particles is more than, let's suppose this is r1 and r2, sum of the radiuses, we call it as not equal to, more, then we call it as discrete system. Are you able to get me or not? And when this distance is either less than or equal to r1 plus r2, they are called as continuous system. Means overlapping particles or in touch with each other, they are called as continuous, while those particles which are separate together where the distance is more than r1 plus r2, they are called as discrete systems. Are you able to get me or not? Is that clear? So first, center of mass we have to study for discrete system, then we will study for continuous system. Are you able to get me? So let us give the heading. COM for discrete system of particles. Is that clear? Now imagine that I have some frame. I have some frame. Frame means XYZ coordinate. Okay. And in that, n number of particles are present. M1, M2, M3, and so on. Word or not? So you only tell me. Basically, this M1, M2, M3 will have all different coordinates. Let's suppose the coordinate of M1 is M1, X1, something like that. So basically, let us write in vector form. Let's suppose the position vector of M1 is R1, M2 is R2, M3 is R3. Yes. Then, in due to these masses, what will happen that in this frame, after the interlink, we can define that okay, there can be a point where this whole masses can be felt to be present, and we call this as center of mass, and its position vector is represented as RC1. How it is represented? Yes. So let us call it. Yes. Okay. And this is our center of mass. Then question arises that what is this RCOM? So let's suppose if M1 was located at R1, M2 was located at R2, M3 was located at R3, and so on. Right or not? So therefore, we have to write vector. Therefore, we have the formula center of mass. So center of mass of the discrete system is given by RCOM is equal to M1 R1 plus M2 R2 and so on divided by M1 plus M2 plus M3 and so on. Are you able to get me or not? Now, question arises that, sir, what we are calculating? What is this center of mass? What is the physical property of this center of mass? Now, many people think that center of mass means some kind of mass of the system. No, center of mass has it's a quantity. So if I write center of mass, this means that you are finding the position of center of mass. Are you able to get me or not? So basically, the net mass means, if someone asks, I asked some students that what is the mass present at the center of mass. They said it's a different mass, but actually the net mass, which is, this means that M1 plus M2 whole mass of the all system, M1 plus M2 plus M3 or whatsoever is there, is all present at the RCOM. And we are, when we tell to find center of mass, we are not finding mass, we are finding the position of the mass, that where this whole mass is present. Are you able to get me or not? Is that clear? So if I know RCOM, then I know x coordinate also. X center of mass will be given as M1 x1 plus M2 x2 and so on divided by m1 plus m2 plus m3, and so similarly y center of mass will be given as m1 y1 plus m2 y2 and so on, divided by m1 plus m2 plus m3. Okay, is that clear or not? Confirm? Yeah. Okay, can we move ahead? uh, Now moving to the next point, so let us give one example. Let's do one question. Okay, if this is your y coordinate and this is your x coordinate, okay, one mass is located at origin and that mass is equal to 10 kg, 0 comma 0. Another mass is 2 kg, 0 comma 0, 2 comma 0. Okay, and third mass is that over here, which is 3 kg, and that is 0 comma 4. Question is, find the position of center of mass. Okay, you can use these formulas. These are the formulas which you have to use. Okay, yeah. It's easy. 2 minutes. X and Y as 0. Huh, huh. X is how much? 4 by 15 and Y? Okay. Yeah, it's correct actually. My goodness, Srishti, if you'll see the paper over here of NEET now, it is of J level. So that is what I'm telling you. What I'll do is I'll share some papers with you over here, whatever I'll get the papers. Got it or not? Okay. No, no, means here NEET paper of LN is like almost J level. Got it or not? Okay. Yeah, so I'll share you the paper of some of the topics. You can see that I can think that that's why they are giving some good level of questions in the exams also. Okay. So okay, I'll share you the papers and you practice them. Got it or not? Okay. So now basically, as we know that we can find x center of mass, which is m1 x1 plus m2 x2 plus m3 x3, because there are three masses, divided by m1 plus m2 plus m3. Yes. So if I look into that, how much is that? 10, first mass m1 10 is at 0 plus m2 2 into 2 kg plus that 3 kg is x coordinate 0. Yes. Divided by total mass, how much? 2 plus 10 plus 3. Yeah, 15 kg. So answer is this is 4 by, and y center of mass. Yeah, y1 m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So which is once again how much? 12 by 15. So it is like 10 into 0 plus 2 into 0 plus 3 into 4 divided by how much? 15. So this is 12 by. So what is the position vector of COM? Basically it is 44 by 15 I cap plus 2 by 12 by 15 J cap meters. That's your answer. Yes. So basically we actually in center of mass calculate the position vector of the particle. Are you able to get me or not? Yes, where the whole mass is felt to be situated, not only situated, where the whole mass is felt to be situated. Are you able to get me or not? Is that clear? Okay, now look over here. Let me give one more question to you. If this is x and this is y and this is 0 comma 0, over here if the mass is 1 kg and over here the mass is 3 kg, but they create a equilateral triangle, means it's not like that this is equilateral triangle I'm talking about. They are placed in such a way that within themselves they create a equilateral triangle with third mass over here. Okay, and let us call it 2 kg, and length of the equilateral triangle from here to here is exactly 1 meter. Then position of find the position of center of mass. Tell me what will be the answer. Mm-hmm. What is that XUM and YCUM? Are actually position of center of mass is XUM and YCUM only. Tell me what is X is? Uh-huh. Uh-huh. Correct. Very good. So how did we did? Basically simple. Like many people think that this is located at half and half, but not. We have to consider that this. Yeah. So you have no. We have to do not do half and half also. Consider 60 degree. Are you able to get me or not? No, you have to consider in equilateral triangle if it is used, consider 60-degree idea. And this x length is what? Basically, in equilateral triangle, this is 1 meter. So this base length is 1 cos 60 and this perpendicular is 1 sine 60, which is equal to root 3 by 2, means the coordinate of 2 kgs and cos 60 is 1 by 2. So coordinate of 2 kg is 1 by 2. Uh, okay, no, but uh, you can use that. Yes, yes, yes. You can use that. You can use that. But mainly for equilateral triangle, go with this approach of finding the coordinates of any time whenever it comes. Okay. Hmm. So basically, XCOM will be given as m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. M1 is 1 into 0, m2 is 3 into 1 plus m3 is 2 into 1 by 2 divided by total mass 3 plus 2 5 1 6. Why not? So this is how much? 2 by 3. Correct. And YCOM, are you getting any background? Are you getting any background noise or what? Is it coming totally? Means it is m2 x2 plus m3 means like tuck 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 something like that, nails parsing or something like that. Yes. Yeah, it's happening in the back. What to do? And this total mass is once again m1 plus m2 plus, so 1 into 0 plus 3 into 0 plus m3 is how much? You can say 2 into root 3 by 2 divided by m1 plus m2 plus m3. How much is that? 1 plus 3 plus 2. How much is 6? So this is equal to how much? 2, yeah, root 3 by 6 meter. So therefore, our center of mass is 2 by 3 comma root 3 by 6. Is that clear? Correct or not? Are you able to get me? Okay. So now look over here. So basically, this is the idea of finding the center of mass if discrete systems are given. Are you able to get me or not? But in that discrete system only, let's pick up one point, 1 minute. Uh, let me see this. Give the heading center of mass for 2 point masses. Yeah, heard or not? So let's suppose there are 2 point particles. Which kind of particles? Uh, 1 minute, sister. I think I'll have to close this window. I'll close it and I'll come. Let me check whether the sound will return. Okay. 2 minutes. Okay. So center of mass of 2 point mass systems. Are you able to get me or not? Now let us talk about that. Let us uh, let us think. Now it should not come, but it is still coming now. It's not coming now. Okay then. So let's suppose there are two masses like this. Okay. Let us bring it over here. The place like this way. And uh, if I consider, let us, this is considered, this is mass m1 and this is mass m2, and they are located by exact distance. Let's suppose some distance d. Okay. Now let us think about one case. Let's suppose their center of mass is existed over here. No, it or not. It's not at perfect center. It is at some distance r1 from m1 and r2 from m2. Okay, is that clear? Are you able to get me? No. The first idea is, the first conclusion is, sir, we know that r1 plus r2 will be exactly equal to distance d. Yes? And, and let's suppose if, second idea is, if we assume that m1 is located at origin. Are you able to get me or not? M1 is located at where? Origin. Okay. So then what will happen? We have to think about that. Yes or no? So how to find x center of mass? Can we find x center of mass or not? Okay. Uh, let us no, let us change this. Then I'll not get that result what I want to make. Okay. Let us assume that if the center of mass is at origin only, means we are assuming, are you able to get me or not? Let's suppose if we consider that the center of mass of this whole m1 m2 system is located at origin, so basically we can say now x center of mass is 0 and y center of mass is also equal to how much? 0. Yeah, are you able to get me or not? So what will be the idea? Simple. If x center of mass is 0, y center of mass is 0, we know that we can write x center of mass as m1 x1 plus m2 x2 divided by m1 plus m2. X center of mass is how much? 0. M1 is how much? M1, x1 is r1 then, and m2 is located at r2. So m1 plus m2 r2 divided by m1 plus m2, which gives us the relation that m1 r1 is exactly equal to m2 r2. Yes. Let us, if I'm just considering the magnitude, let us consider the magnitude. Okay. M1 r1 is equal to what? M2 r2. What is the meaning of that? Mm, 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 mm. See the meaning. First case A, let's imagine if M1 is greater than M2. This implies what will happen? If M1 is greater than M2, then that means that R1 means R2 is greater than R1 or not. Inverse will happen. Correct? Yes? Yeah. So that means that if M1 is greater, then R2 becomes much more greater. That means center of mass is much more nearer to the M1 or not. Tell me yes or no. Yeah, so this is the conclusion that the center of mass hangs closer to the, yeah, closer to the heavier mass. Are you able to get me or not? Are they yes or no? And second conclusion which we can draw is that this position vector r is inversely proportional to mass. This means that R1 is to R2 will be equal to, or you can say proportional to, M2 is to M1. Are you able to get me or not? Clear? So, yeah. So basically, if I know M1 R1 and if we know M2 R2, then question arises that what is R1 and what is R2? So R1 plus R2 is equal to D. R1. So this implies that R1 is exactly equal to D minus R2 or not? And that can be written as D minus R2 can be written as how much? D minus R2. R2 is D minus M1 R1 divided by M2. Yes. So you can replace like that way or subtract like this way. So R1 will come as, I think it will be M2D, and if you bring M1 R1 over here, so it will be M2D by M1 plus M2, and R2 will be M1D by inversely proportional to each other. Are you able to get me or not? Are you able to get me? Is it totally clear? So this is the idea which you have to keep always in your mind. Okay. Okay. So Srishti, like today, I will keep a class of only 1 hour.